All right, so welcome back. Today we're looking at 7.5, graphing inequalities or systems of inequalities. And we're going to focus on just initially graphing an inequality and then making a leap up to a system. Now, reminder that yesterday we spoke that we're skipping 7.6 for now at least, which is optimization by linear programming. It's a super valuable skill, but if you're optimizing stuff in any real sense, realistically, you're probably going to use calculus to do it anyway. We can check it out as an application of this, but it's not going to show up on the test tomorrow. Cool. So in graphing inequalities, there's not a ton of stuff that we need to say. Cool. Right off the bat, we will have entire regions of solutions. Okay, if we think about graphing a regular line, the line or the curve doesn't matter that you physically draw on your page as you graph it. You are drawing infinitely many points in that curve. When we do this, we might or might not get that infinitely many that the equal has, but any single graph that you draw, as long as it's continuous to both directions on the coordinate plane, cuts the entire coordinate plane in half. That's a weird idea in some situations. Just to highlight it, to show you why this is so weird, you don't need to graph this, I just want to think about it. And you know what? We'll talk about it when we actually do an example. Now, to do this, two little comments I'm going to make. The same essentially as graphing an inequality. Nothing changes. As graphing an equation, nothing changes other than two little additional parts. When graphing, we graph the related equation, which we'll sneak this in and see what this really is. I can speak to it now, but I don't think we need to write it down. If I have y is less than or equal to x, or even just less than x, and I said, if you could replace one thing and put an equal sign in it, I'm going to write it, but you don't, okay? Here's an inequality. If I asked you to replace something in there with an equal sign that doesn't wildly change the way you think about it, where would you put the equals? You probably wouldn't put it out here, right? That seems odd. Where would you put it? You're going to replace something, it's going to feel natural. It's y equals, right? This is our related equation. Now, we will use that because we'll just graph it as though it says equals, and then we'll do the follow-up kind of thought with it. We graph the related equation, where I'm going to make a little follow-up to here. Solid if, what makes a solid line with an inequality? So forget about inequalities. If you graph a function,
It's greater or equal to.
or equal to. If you graph a function, it's equal, it's solid, right? Solid if equal, so greater than or equal to, or less than or equal to. And that's supposed to be an arrow. And I'm going to leave this little blank spot for now. What if it's just greater than or less than? Dashed or dotted. I'm going to write dashed. Cool. For this, I don't use my calculator, just so you know. I don't like using the calculator for these. There is a way to do it. Anybody in here know how to make dashed lines and inequalities show up on your calculators? Okay, you can look it up if you want to. You can do it, but it's easier just to graph them for our own purposes most of the time. Okay, beyond that, we have entire regions of solutions. After we graph this, it's solid or dashed, and I'm going to leave a gap here just so this one stands out a skosh. The last little section, if you think all the way back to inequalities, we looked at them briefly yesterday, there's one more step. Hypothetically, we have a dashed line or curve on our graph. What's the last part? So there could be a hole. I like that thought. I'm going to address something else. I don't think that I have any prepared today that have a hole in it, but they could. The last little piece of this that I want to just make note of is pick a test point. Not on the graph. And when I say graph, what I mean very specifically is a graph of y equals f of x, or like your line or curve. Pick a point not on the graph to determine shading. Because when we graph inequalities, we shade literally half the plane. Shading. There we go. Okay. You may not remember this, like every single part of it going through, but does everything that we've written here sound kind of familiar and it rattles like a memory in your brain? Okay. Let's jump in. How hardcore do we want to get? Good. We're digging deep. This example is going to seem hard. I promise it's not. I want you to talk with your group. If you need to use your notes, you can. We're going to graph one inequality here, and then we'll get more practice because we're going to move on to systems of inequalities. So here we go. I'm just going to say sketch. We don't have to go crazy with it. But let's check it out. I have, in parentheses, to begin with, the quantity x plus 2. And we're going to square it. But I'm going to add to this the quantity y minus 2. And I don't know why my 2's wind up different. It happens pretty often. I'm going to square this too. And this is less than 16. Baller. Okay. Could you theoretically FOIL everything out and try to solve for y? Don't do it like that. With your neighbors, collectively dig through your memories of things that we have talked about this year. We have graphed this with an equal sign instead. Talk with your neighbors, see if we can't remember what it is. I'm going to give you like a huge shove. Chapter 1. Okay, Rafa, you weren't here on the video when we hit it, but good call. This is a circle. This is chapter 1. Pretty sure it's 1.10, but I don't have chapter 1 in front of me. Looking at this, before we jot this down, because we haven't seen these in a while, I'm going to make a few little notes just to remind us. The center is at HK. What is H and K in hours? Love it. -2 because it's x minus h and it turned into a plus. Remember, it's that weird opposite idea. We have a center of our circle at -2, 2. What's the radius r of our circle? 4. How did you get that? Good. Square root of 16. And then I'm going to make one more little comment here that it doesn't fit directly into our circle. The fact that I have less than, I've written the related equation kind of below. Dashed or solid? Dashed. Okay. Those are the only things that I need. And then we'll add a little bit more once we get the graph. If you're graphing a circle with a radius of 4 and a center at -2, 2, I think we're primarily going to be over here. It's not going to be entirely in quadrant 2, but a lot of it's going to be in quadrant 2. Okay. Now I'm going to plot a point for the center because it's going to help me graph it, but the center really isn't on the circle. When I'm talking about on the circle, we're talking about on that circumference that goes around the outside. That's the actual equation that we're graphing. The circle, just the center of it, helps us to graph it. Do I have enough stuff to go perfectly to scale? I don't. So check it out. There's 2 and 2, just so I can tell really clearly what's going on. And I'm going to plot this point really lightly. What did I just plot? It's very small right here. And I'll make it actually huge, and then I'll just take it out later. That's the center. Okay. Is it really easy for me or you or anybody to measure out 4 units that direction? I don't think so. Like, it's really hard for me because even if you think it's diagonal, remember each one of these little squares is, okay, this one's going to be really nicely in this situation. You were right, Rafa. Did you put a lot of thought into it, or did you just go with your gut? Okay, I'm going to ask this differently because this is coincidental. Everywhere on the circle is 4 units away from this, right? Now, what's the easiest directions you can count on a graph? Up, down, left, and right. Check it out. 4 units to the right. I know my circle touches this point. 4 units up. It must touch this point. Weird, that does not look square when I turn my head here. These 4 points are on my circle. Kalisha. Because HK is our center, and we picked it out if it's x minus -2. Yep. Okay, with these 4 points, don't make the mistake that I almost did. I'm going to go through and I'm going to draw a dashed circle. And once I've done this and I'm convinced with it, I'm going to get rid of my center point because I don't really need it. It's not on my circle. That is what we just graphed. I love the weirdness of this next little idea. We have 75% of this problem done. However, something else has to happen. We don't just draw a dashed line. We said at the very beginning that graphs of these, or graphs of inequalities, they have entire regions of solutions, shaded regions. And we need a test point to pick. Whether, I would encourage you should always write these down like actually here, but here's what I like to do. I'm going to pick a point to test, any point that's easy, that's not on that dashed line, curve rather. Is there an easiest point that you guys can be pretty confident is not on the dashed line? Okay, I'm going to, by default, unless my line happens to run through the origin, I'm going to test 0, 0 every single time. Now, 0, 0. Cool. When I say test this, what we're looking for is points that will make my entire inequality true. So let's just plug into my original and determine whether it's true or false. If I plug this test point 0, 0 into my original inequality, I get, if I just do 2 squared, do you guys see where this came from? Where? 0 plus 2, because I'm plugging it in for the x. Okay, if you need to write it, please do. 0 plus 2 squared plus 0 minus 2 squared. And we're making the claim that this is less than 16. I'm going to put a question mark because that's what we're confirming or showing to be false. Let's do, without a ton of work and extra steps, this is 2 squared, is 4, right? This reads at 4 plus, what is this going to get replaced with? What's negative 2 squared? 4. We're claiming that 4 plus 4 is less than 16. Is this true? Okay. I will write this out if you guys want to. I like to denote it like true. I know that that is correct. Okay. If you want me to write it, I will, but I'll wait till everybody's done because I want your ears open for this one. We picked a test point in one of the 2 possible regions on this graph here. Can you guys tell me the 2 regions that I see when I look at the plane? There's an inside of the circle and there's an outside of the circle. Okay, we picked a point that was where? Inside or outside? Inside. The point that we tested inside wound up being true tells me I'll shade this region. I'm going to shade the region that's true. So everything in here gets shaded. Everything. And I'm going to use my other one because I have the ability to do it. I prefer this if I'm shading. It's a little bit nicer on mine. Okay. Here's a neat idea that's just weird. It doesn't feel right. I've cut the plane into half. How many points are inside the circle? How many points are in that shaded region? Infinitely many. How many are in the outer region? We have half the plane right now. And it's a weird idea because I can see it clicking and you're thinking, what, do we really? Turns out, maybe. You should dig into that. I like to think so. Cool. Doable? All right. What if, hypothetically, this had been false? I picked a point inside and it's false. Outside. Everything outside. Okay. There are shortcuts. If you have y is greater than, some of you may look at it and go, oh yeah, y is greater means above. That is a weird idea when you start getting graphs that do kind of weird things. That above doesn't mean the same thing if you check it here or here. Okay. Pick a test point, 0, 0 if it's possible. Okay, we're going to graph more inequalities, but instead of just doing only inequalities, we're going to do systems. So we're in our second piece now, which I would argue is the bigger. Questions here before we continue on? Okay, I was just born this cool, Fern. Thanks for asking. Just natural, I don't know. I got to work at it a lot, I guess, but... Okay, all right. I made that joke a bunch, right? I need new material. Cool. Let's do systems of inequalities. Systems of inequalities. Iniqua.
Did you post the video yesterday
I
for this class?
I think so, but I can double check. I did come in this morning and my... Huggins, did you get Kleenex?
I didn't get any.
Okay.
So
Will you go ask them for a couple
I
boxes?
don't know where they're at. Sorry.
Oh, they give them to you in the office.
Oh.
That's cool. All right. We're going to look at systems of inequalities. Now, for this, we're going to make a couple comments. Once again, we get whole regions of solutions, typically. Our solutions, however many there are, or if there aren't any, this still works. Our solutions must be true in every inequality, or for every inequality in the system. Okay. Every single inequality in the system has to be true. We take one more step while we're doing it because it's good practice with the systems of equation stuff. We're going to get one of two possibilities or one of three possibilities, but let's say there are solutions. If we do wind up with some solutions, we're either going to have a bounded region, so it's going to look like a polygon or at least a closed shape, or there could be the situation that it goes off to infinity and it's completely unbounded. Okay, those are the possibilities. We're not using these a ton yet, but let's check this out. The one piece that I want to stress is we're always going to find the intersections. We're going to find the vertices of these regions if we need to. So, or if they exist. So here we go. We're going to sketch the system and find intersects. I say intersections because it feels a little bit more formal. All right. How crazy we want to get? Good. Okay, we're going to do an ugly-ish one together, and then you guys are going to do an easier-ish one with your neighbors. Cool. Let's dig in. On A, we have a system of two equations, and I'm going to use different colors for each just because I can. It'll make shading a little bit more clear as well. So let's see, this lovely blue color. I want one of these inequalities to be x plus y is less than or equal to 1. And the second, and I'm going to use red because it's so different, we're going to say is x minus y squared. X minus y squared is greater than negative 5. Okay. One of these is easy to graph, relatively. Talk with your neighbors. I'm going to give you like 30 seconds for each. 30 seconds, discuss how would you graph the blue one. 30 seconds afterward, how would you graph the red one? I'm not asking you to actually graph it. I just want you to think about, if you want to start it, you can. But I don't think we need a ton of work for it. Talk it out. 30 seconds for each. I'll let you know when 30 seconds is up, starting right meow. Who feels that when you look at this, you say, I'm going to subtract an x and I'm going to graph it? You could. It's not a huge deal to do that. You could probably graph that function without ever plugging it into your head. I have an alternative suggestion. Do you guys agree that the blue one's a line? Okay, it's not in slope-intercept right now. It's not in point-slope. What form is it in? Do you remember the third form of a line? That's right, it's standard form. Okay, with that, don't care if you remember that language or not. You can change it pretty easily in this case. How many points do you need to graph a line? 2. Now, I can pick any 2 points, right? For example, if I wanted to know the y-intercept of this line, any line, the y-intercept is when x is what? 0. If I plug in a 0 for x, I get the y-intercept at 1. If I plug in a 0 for y, I get the x-intercept. That happens at which x value? 1. I know that 0, 1 and 1, 0 are on this graph. That's how I would suggest doing this rather than thinking about slope and stuff. Okay. This second one's a little bit harder. How did you guys go about graphing the red one, or how would you? So I'm going to start graphing here, and I'm going to make sure I have space to see on either side. Okay, not everybody at once. Okay, JV, what do you think with the red one? I don't know that there's a wrong necessarily answer. How would you go about graphing the red one? Add 5 and then probably add a y squared. Okay, you can solve it for y, right? We normally write functions y in terms of x. That means we solve for y and it has an x in it. If I gave you this one, don't write this down, but if I said x squared minus 2, do you know what that graph looks like? Like, I need some sort of yes, no, just so we can see. Is it a parabola? Has it been shifted left or right? Do you see a minus h or anything like that going on? Okay, has it been, do you see a number in front of the x squared to make it steeper or less steep? Do you see anything that's moved it up or down? This is the graph of y squared, or y equals x squared, that looks like this, and it's been shifted down in that big one I gave us, 2 units. That's it. Now, we're so used to saying here's a function y in terms of x that we forget that there's a whole other side of stuff that we could think about. If I gave you this equation, well, this is now a function x in terms of y, right? It's still y squared, which makes me think it's a parabola. But instead of opening like this, what do you think it's going to do? Sideways. Has it been shifted left 5, as in down on the y on that axis, or up 5? It's been shifted down because that minus 5, right? Check it out. We can graph these without doing a ton of work. If you need to do a little table to graph it, is that okay? For sure. I would strongly recommend JV and anybody else who would go that solve for y route. Don't. You would have to wind up graphing y equals positive square root of something and y equals negative square root of something. Gross. Let's just think it out. Reminder, if x is 0, what would y be if this were just an equal sign here? When x is 0 for blue, y is what? 1? Do you guys understand where I'm getting these numbers? Okay. What if y is 0 on the blue one? If y is 0, x would be equal to 1. How many points did we just find on that blue line? Can I graph that? It's a line through 2 points. Cool. Before I do it, I need to think to myself, solid or dashed? It is a solid line. Boom. Okay. Done. Now, you do not have to graph in different colors, but I would strongly suggest this is a graph of x plus y equals 1. That's the related equation, but it's solid. Okay, for the second one, just a reminder, it's a parabola. I would take one step. X equals y squared minus 5. It's a parabola in the y direction, or sorry, in the x direction this time, that's been shifted left 5 units. Here is 5 units left, and it's a parabola. Now, even if we have it here, let's just pick some y values and see what x it spits out. Give me an easy y to plug in. If I plug in a 1, what's 1? So if I plug in y is 1, what x does it give me? 1 squared minus 5. Negative 4. Cool. Give me one more. So it's a quadratic, so I know it's going to have symmetry about its vertex. Give me one more nice y value you could plug in. 0, we just didn't say it. If we plug in y as 0, we get x equals negative 5, which we've already gotten. So we picked 1. Could I pick 2? What's 2 squared minus 5? Negative 1. And that means I get this point here. And this does look like a parabola. Before I graph it, what am I going to think about? Good. Is it dashed or is it solid? It's dashed. Okay, it's terrible dashing on that part, but that's okay. All right, we have this lovely parabola, and I'm going to fix that one because it's going to bug me if I don't. Okay. For this, don't write these down on every problem. I guess you can if you want to. I don't really care. I want you to find me how many regions we have cut the plane into. And I'm going to go ahead. I'm just going to do the first one. I'm going to do mine in this obnoxious yellow color that's hard to see. I think this is one whole region. Notice that these axes don't separate it. We're only looking at the curves. Everything out here between the parabola is one region. Can you guys see that yellow at all? I'm going to use black, and it's just going to be terrible in the I'll use green. Here's region 1. Count me the rest of the regions, not with the axes separating stuff, but only with the graphs. I want to know how many regions we see on the plane. Do you understand what I mean by this region? Okay, so one, extend this further. Make sure we can see it across. Like it can be. I don't want to say that it's bad, but it can be bad. Go a little bit further just so I can see it. Okay, I'm not going to color your whole page, but check it out. If these go forever, right? Yeah. Means there's a region that's between the parabola and this here.
This
so
is stuck
one.
in here. Yeah.
Here's 2 inside of this. There's a third one up here that's in this. A fourth one right all the way outside, and the fifth one is going to be an outer triangle region. I think so. I counted 5.
How are you so precise where you getting the points for the variety?
So instead of picking x's and seeing what y it spits out, we can, because I have it solve x equals something with y, I'm picking y's and seeing what x it spits out. I'm just doing it backward because we solved it backward. So if I pick y is 1, 1 squared minus 5 is negative 4. So go to where y is 1, and now it's when x is negative 4. Yep. Okay, so just to see it, the 5 regions. I'm going to undo this here in a second. Here's 1, between these parabola, out here forever. Region 1. Okay. 2, depends on which way you go, but I see this region. I'm going to get rid of all this. Everything outside of the parabola forever up here. 3, everything here until we get to this function. Everything out here forever and ever. 4, this inside piece. And there's one more region hiding. If you don't draw your graph well enough, it's hard to see sometimes. Here's the last region. Out forever. There are 5 regions. Do you see them all? Question? Interesting comment? Kind of interesting comment? Funny thought? Compliment for me?
You're awesome.
Awesome. Cool. All right. So here's what I recommend. We only have 2 graphs right now, and there's 5 regions. It can get kind of awful to deal with, right? Imagine if we had like 6 graphs going on at the same time. It sucks. I'm going to take one more little moment to make sure that I write each equation here. This is a related equation, x equals y squared minus 5. And if you want to, you can even go through the process of using the inequalities, but I haven't shaded anything yet. Okay. Do you guys see a point that is not on either red or blue graph? 0, 0. So let's check it. I'm going to check it with each one independently. We have 2 equations or inequalities that we're dealing with. I'm going to test 0, 0. Now, I'm going to test it into each of these inequalities simultaneously. And really, really important, if you don't get something that I do here, ask questions, because this is not the way that I've ever seen it done in an algebra book, but this is the way that it's worked for me for years. Okay, let's test in blue first. If I plug in x and 0 with x and y with 0 and 0, my inequality reads 0 plus 0 is less than or equal to 1. Is this true or false? True. 0 is less than 1. Now, I'm not even thinking about the red one right now. If it was only the blue graph, are you guys comfortable saying everything down here would be shaded? That's the region that includes 0, 0 with ignoring the red graph. Now, here's what I suggest and what I make people do. When I look at this, I'm going to keep the red graph in mind. I'm not going to shade with like lines and try to look for a checkerboard pattern or something later, which is something that I've seen done. I don't know how you guys did it last year. Here's what I do. I know that any region over here to the left and below, right, is how I see it, would get shaded. I'm going to put an X in every region that would get shaded with the red one still showing. There's an X in here. How many more regions am I going to shade? Just the outside. Now, when I put them, I did it very intentionally here so that I don't get goofed up and try to include the axes when I'm looking at this. I'm also going to do it here so I don't think that the x-axis splits the region. There's only two regions you need to shade. It's inside the parabola and outside the parabola. Everything down to the left of the blue line. I've only put X's there. Now we're going to shift to parabola land. Okay, I'm going to switch to red for my X's. Can we still use 0, 0? Faux show. Let's look. If I use 0, 0, I get 0 minus 0 is greater than negative 5. Is that true or is that false? 0 is greater than negative 5. Here's 0. There's negative 5. Hey, 0 is greater than negative 5. So any region in my parabola, disregarding the blue line at first, that has 0, 0 in it is fine. If we look at just the parabola, there's only inside the parabola and outside, right? But it's cut into two sections by this. Here's the inside. Here's the outside. Have I lost anybody yet? Okay, did you guys do it? Have you ever seen it when I mentioned the lines that you guys do things like this? You can look for where they cross over. I think that gets ugly, especially if you have more than two equations. How many inequalities did we have? 2. We only had 2 inequalities in our system, right? Is there a region that got hit twice? It's the inside here, right? It's this region. Check it out. Here's our infinitely many solutions. It happens to be in that middle region there. This is where our solution set is. All of these are our answer. Any point in there is going to satisfy all these inequalities. Now, my other piece that I want you guys to do, we can do it here together if we need to. There's one more part. We've got the intersections. We've got the region. How do we find the intersections? Now, I can't tell, is it silent because nobody wants to answer? Nobody knows. Cool. What's the intersections I'm talking about?
The solution set is intersecting. Like the...
Can you point, I'm going to start moving my cursor. You tell me which way to move it to get to one of the intersections you think I'm talking about.
Down to the green.
So go over here. I'm in the green, okay?
I don't know.
You're close. Anybody have a different idea? From where I'm at, where do I go to get to an intersection? Up? That point? I hate that I did it like that. This is an intersection. And this is an intersection. Because I'm looking at where my equations intersect. Can you find me those? Mm-hmm. Now I'm going to rephrase that because you can. Find me these. You are going to use the related equations. I'm going to help here just to make it look, not really help, I'm just going to change the way it looks. Here is my system of equations. Solve it. Don't care what method you use. I know which one I would do, but I want you to solve the system. Find me these ordered pairs. This certainly looks like it's going to be negative 1, 2 to me. Looks that way. Pretty sure it's going to be, but I want you to verify it. Find me the solution to this system so we can label these vertices. If you didn't notice, when we add another line, this is why I'm so crazy about you labeling your equations, because to find them later is going to be a nightmare if you don't write down which equation it is. Cool. I'll give you a minute. As you're doing it, I'm going to set up another problem for you. So, I don't know, at some point I forgot to resume, so my bad, Riley. Here's a factorization for the system of equations over here where we set red and blue with substitution. Let's do B now. Cool. Oh, okay. From the unisex too. I don't know that I agree with you. I don't know that I disagree with you, but I don't know that I agree with you. What's your test? So let's see. So you change these around so we order. So I know it's everything underneath. Start off with that. And then 0 plus 0 is 1. So here's 0, 0. And this is x plus 1. And then 0, 0 is false, right? I wouldn't rearrange them. Just so you know. Like you can, if you're gonna graph them, plug them in, like make sure it's written immediately next to it so you can tell which one. If you recheck this one, which comes from here, you should put everything. I would double check it. Double check all of them. Okay. Do you want to talk through the shading part here? Okay. For this, what's the easiest of those three functions? The y one, everything below it. Now, I know that there's 3, and I don't have to count the regions necessarily, but everything below this. So it's going to be in this region, and I'm always going to put it on the axis so I don't get goofed up. It's going to be this region. It's going to be this region. I'm even going to go up further to put that x. And it's going to be this region. All 4 of those regions get hit by y going downward. Everybody cool there? Okay, let's do the red one. What test point would you pick? 0, 0. I would get 0 plus 0 is greater than or equal to 1. True or false? False. So from the red, remember this cuts it in half. Everything with 0, 0, which is all of this, is false. None of that gets shaded then. Which means the other side must get shaded. So I see that there's one here. There's going to be one in this region. There's one over here. And one over here. Okay, one more region, test point you would use. Is it 0, 0 again? Good choice. 0 plus 0 is greater than 1, true or false? So I know as soon as it's false, nothing down to the bottom left region is going to get shaded, which means everything up and to the right of it. That region, that region, that region, that region. All of those. What region got hit thrice because I have 3 inequalities? The middle region, check it out. Here it is. That little triangular region is all infinitely many of my points. Okay. These systems, as long as you label your stuff, piece of cake to work out. This ordered pair, which I'm not doing anything right now, right here is where x plus y equals 1, or negative x plus y equals 1, and y equals 2 intersect, right? Guaranteed it's something 2. Has to be, right? This line, similarly, is where green and purple intersect, and the y value is always 2, so I know it's something, comma 2. We don't have a ton of crazy work to do to solve these systems. If I want to know what the x value is when y is 2, can you just plug in a 2 right here and solve it? If I do that, and I'll do a little bit of scratch work off on the side, negative x plus 2, and I'm going to use the related equation instead, equals 1. What do we get for x? Negative x equals negative 1. 1. Hey, that does look like the point 1, 2 to me. I'm using substitution, but because it's already been given as one of the variables, I just have to plug in one number and get it. I don't have to go back again and find the other value. Same thing here. If I plug in a 2 into green for y, I get x plus 2 equals 1. X equals negative 1. The only one that's even a little bit ugly is right here. Which equations would we have to solve the system for to find that last point? Colors is fine with me. Green and red. So I need to know when is it true that negative x plus y equals 1. And the other equation, notice I'm not changing into the y equals anywhere. What method would you solve this with? Elimination, and I don't even have to change anything, right? Because I already have an x and a negative x. If I just right off the bat without changing, add straight down, 2y equals 2. So I know that the y point here is what? 2. I'm going to hate this, but I ran out of space. So y is 1, right? What's x? If y is 1, 0. Does that look like it agrees with my graph? And we done. Okay. I'm going to show one more. I'm not going to make us do another example, but I want us to think about it. As long as you work along like mentally with me, I'm cool with it. Okay. Before we move on, questions. Does it feel
How'd you find the intersection?
So for each of these, I did most of it just in my head. Do you agree that anything on this purple line had better be at y equals 2?
Yeah.
Okay, so I already know that this y value is going to be 2. So I just look and say, oh, when y is 2 in this equation, because that's what it intersects with, what's x? And I just solve it, which is this stretch work right here.
Oh, okay.
I'm just using substitution, but it's not like I'm getting,
I see.
I just get the first number for free. Okay, last one. I want you to follow along. I'm just going to talk about it. All right, and is the graphing part crazy hard, or is the graphing okay? Are you guys going to keep solving it for y equals still? Okay, so let's look at one where maybe you won't. Negative 3x plus y is greater than 2. Your choice if you want to write it. You are cool to just work along, or to follow along as long as you're paying attention. And negative 6x plus 2y is less than negative 2. Okay, this one's going to look stupid because I'm going to use a blue coordinate plane because I absentmindedly picked x already to be black, or the first equation to be black. Okay, check it out. I want to make sense of this as easy as possible. To graph the black one, you could solve it and do 3x plus 2, and that's not terrible. Okay, but check it out. If y is 0, what is x? If I replace this with an equal, on the black one, if y is 0, negative 2/3, right? Everybody okay with that? Because it's like it's gone, and I just divide by negative 3. Okay, so I know the point. I have an x-intercept at negative 2/3 because y was 0. If I pick this to be negative 1, and this is 1, this is going to work out nicely, and we'll just stay consistent here. Here's 1 and negative 1 there as well. So 0 and negative 2/3 in black. All right, so eyeballing it, there's negative 2/3. What if x is 0? What would y be? On this black one, if x is 0, that's just gone. Y would be equal to 2. I don't think it's hard to graph it either way, but I think this is super easy to graph it this way. Like, you don't even have to change anything. 2 points make a line. Can I draw this line? And then it's going to look like I make a mistake. I just want to be clear, I don't. Because I know that it's easier for me to do it this way. There's one of them. Cool. For the second one, let's do the same thing. If x is 0, it's just gone. 2y equals negative 2. What's y? Negative 1. I know that when x is 0 for the green one, y is negative 1. That's not green. Right there. Okay, if y is 0, what's x? 1/3, about there. And it's dashed again, but I'll pay attention here. Here it is. I'm not putting a crazy amount of faith into this, like I'm just using it to sketch, right? It'll be dashed. We need to decide where to shade. Can I use 0, 0 again? I wish I'd had an example where we can't. If any of your curves run through 0, 0, don't use that as a test point. Okay, so let's try 0, 0 with the black. 0 plus 0 is greater than 2, true or false? False, which means I'm going to use gray so I can see it a little bit easier. If that's false, everything over here, not including it, just got shaded. Cool? Okay? What about 0, 0 with green? 0 plus 0 is less than negative 2. 0 is less than negative 2 is false, right? So it's not over here, it's going to be this side. What's weird about this answer? There's no overlap. None. There's no solution to this system of inequalities either. Be on the lookout for that. Cool. All right. That's all I've got. Tomorrow, do we have class? Hey, we have our final. Kind of. It's not really final. It's our final test of the semester. Tomorrow in class, we will use, I don't know, 10 or 15 minutes checking the homework that I'm about to give you. I will give you 30-ish to 40-ish minutes to go ahead and prepare a note card, because I want everybody to make a note card, even if we're using open notes, because if you don't study at all with open notes, it's going to not go any better. And then we'll take the test. Cool. Or, just hear me out, we could do 7-6 and then take a regular hour-long test on Thursday.
Do what?
Just kidding. I don't have you guys Thursday. That's out the window. Nothing. All right. I bet I do. You guys want a few practice problems? You just want like a couple really hard problems?
Let's get some practice. If we're gonna,
All right.
if we're gonna take a test tomorrow.
Yeah, that seems reasonable to me. Okay, homework. Last one of the semester. Homework 7.5, which you're going to find waiting lovingly on page 515. Okay, can you do more problems if you need more practice? Okay. 42 through 46, even. Just a pro tip. As I'm looking at the book, if I look at 42 and go, oh, I don't know how to do it, 41's like very similar. And there's detailed solutions in that book, or there's detailed solutions on Calc Chat. Cool. All right, 5 minutes. How about you can get through one or two of them? There's only 3 problems. If you need more, do more. We'll have a test tomorrow. And remember, the test is going to be section 7.1, 7.2, 7.4, and 7.5. If you want to get a head start on your note card, I'll tell you, even with open notes, the better the note card, if you spend the time as if you didn't get open notes, I bet you don't even need to look in your notes, realistically. But knowing where all the stuff is going to come from doing your note card. I'm going to require it. Whether you do it tonight or tomorrow in that 30 minutes, everyone's going to make a note card before you take the test. Cool, cool, cool.